Hey, how's it going? My name is Michael Lyons, and this is for the motor's midterm number 1. As you can see, I have a parallel DC motor in front of us using a field coil. This is as opposed to a series DC motor using a field coil or maybe a permanent magnet. As a power source, I have two 3.7 volt batteries in series. Initially, I tried using a 1.5 volt and also a 9 volt, but I was unsuccessful with those. So the main things to note are which direction the current is going to go and also the direction of the wrapping or turns on the field coil. So on the field coil, we have going from left to right, wrapping around, and by this, we're going to end up having a upward B force if current's going from positive to negative. This upward B force is going to come up into the armature, and in addition to the current that's going from left to right, we'll be able to have a force coming towards us and have it rotate towards us. So if we look at the diagram here, you can see that exactly what I was saying. Based on Ampere's law, we find out B, which is going upwards, and then based on Bill's law, we have current going from left to right and B going up. We'll have a force coming towards us. So now, say we swap the polarity. So negative is on the opposite side, positive is on the opposite side. You can see here in example 2, current from right to left, and also current going from right to left through the field coil. That causes B to go down, and then as a result, we have a force coming towards us still, even though we reverse the direction of current. So the main reason that we see this happening is because our field coil still acts as a regular magnet. Since we cannot have magnetic monopoles through Gauss's law, we know that we'll still have B, and it will still allow the motor to rotate in the same direction. The only way we could change the direction of the motor is if we had a separate source on the field coil and the armature. If we had opposite direction and polarity for current, we could get it rotating in the opposite way. So let's see if we can test it out and watch it actually run. So if we get it moving towards us, and we'll give it some power, and it continues to run. Now we'll swap polarity and see if it goes in the same direction like our theory says. And it holds true. The motor still rotates in the same direction based on the laws stated. And this is a very simple motor design, but by understanding Bill's law, Ampere's law, and also Gauss's law, we can determine that it's still going to move in the same direction no matter what. And yeah, so there's my project, and hopefully I'm able to get an A on it. Thanks.